My talk today is entitled Planting of Southern Yellow Pines. So here in Mississippi, we basically have 4 southern yellow pines / shortleaf, longleaf, and loblolly. And there's spruce pine as well, but loblolly pine plantations, of course, dominate the state, both in terms of the acres as well as the financial value of those plantations. And then longleaf and shortleaf and slash, of course, have some acres as well. And there's some restoration efforts, obviously, with longleaf. Longleaf and slash are basically confined to the south, and then shortleaf and loblolly historically were found across the state. So today's talk is mainly going to concentrate on loblolly pine. There's 3 main types of reforestation. There's natural, seeding, and planting or plantation. And this presentation is going to cover the planting and plantation. Seeding at this time is not very common, but perhaps with time it could become more common. For the most part now, at the current time, we're planting seedlings. So these are some things we're going to talk about: planting density per acre, configuration, container versus bare root, seedling type, and so forth. So you have 2 types of ways to get the seedling into the ground. That's machine planting and hand planting. And often hand planting could be a little less. It kind of depends on the operation. But machine planting maybe can help you get the better depth and more consistent spacing than hand planting. But both methods are certainly applicable. But we can alter the planting density, and this can be useful to reduce the seedling and total seedling planting cost. So you have the cost of buying the seedlings and, of course, the cost of putting the seedlings into the ground. And if you're bedding or ripping mechanical site preparation, you can reduce your reforestation costs because you'll have fewer passes. So here's a bed here, and you can imagine if I'm taking out every other bed, I should be able to reduce my labor cost, my fuel cost, have less environmental impact, perhaps have less heavy equipment use with erosion perhaps. And here we can see rectangularity with lower density. And here's 454 seedlings per acre in the rows, and then rectangularity, which is even spacing out the rows even more, compared the number of passes here to the number of passes here, and the fuel associated with that, erosion and so forth, time. So you can reduce your reforestation costs as well. And then this could even be advantageous during the first thinning to help with getting equipment access, the fellow buncher and the skidder through the rows easier particularly during the first thinning, during a row thinning. And then banded herbicide application. So you're coming over the top and applying herbicide over the top of the seedlings. And of course, if you have fewer passes, should reduce your fuel, your labor, and you will also environmentally, you should put out less chemical, and you're going to purchase less chemical. And then of course you have this understory vegetation biomass relationship to where as stand density increases, the amount of light, moisture, and nutrients to the understory decreases. So I can delay that amount of time to where you start to see this drastic drop in the amount of understory production, and that can be beneficial for wildlife habitat. And you can see that here. I can delay this time to this crown closure. I can delay the time to the crown closure both in terms of the understory vegetation and wildlife habitat, but also the need for thinning. So here we can see age. This is a lower planting density, and this is a very high planting density. And you can see that the high planting density gets up to the crown closure very soon, around age 6, 5, 6, 7, right? And you have a delayed crown closure in the lower planting density. So I can delay this time to this crown closure and get benefits for wildlife habitat as well. And delay the timing to the thinning, particularly in today when it's very difficult to conduct a first thinning. Then I can also, by lowering the planting density, I can increase and alter the amount of product classes. So saw timber and chip and saw, and we can see that here. Stumpage values for pulpwood 0.75, less than $1, versus chip and saw, which is about $10 a ton, and then pine saw timber about $20 a ton. Here's in the Southwest. Pulpwood's a little bit better relative to the state, but nonetheless, right? I don't want to be growing pulpwood trees. I don't want to be in the pulpwood market. I want to be in the chip and saw market, but really the chip and saw prices now are really bad. So I want to be in the saw timber and if I can, be in the poles. But even the saw timber is relatively bad to what it has been traditionally. But certainly that's about 20 times more on the state. So a ton is a ton. A ton is 2,000 pounds. If I have 2,000 pounds of pulpwood, that's equal in weight to 2,000 pounds of saw timber. That 2,000 pounds, I should say, is worth 20 times more on the saw timber. So most definitely, if I can get to that saw timber production earlier by decreasing the planting density, reducing my planting cost, perhaps site preparation cost and so forth, plus I can increase the amount of that more valuable saw log, chip and saw through time. Here's your saw timber. The high planting density age 25, there's no saw timber at all, and you can see around age 13, 14, I'm already getting saw timber in the 303. We're usually going to plant about 400 to 600 seedlings per acre now. And I can pair that then with rectangularity, so I can even have fewer rows on my plantation, fewer passes. I can reduce, may not be able to reduce the seedling and total seedling planting cost, perhaps the planting cost, particularly if I'm machine planting. But if I'm bedding or ripping, I can reduce the cost. The number of passes, as I've already mentioned, the banded herbicide applications on fewer rows could be advantageous during the first thinning to get that fellow buncher skidder during the first thinning. That way I don't have to do a row thinning. I can do a logger select, or I can do a select thinning on the first thinning. Because often we're going to do a row thinning because the spacings are too tight. So I got to do a row thinning. In order to get into the plantation, I have to take out a row. But the problem with a row thinning is when I do a row thinning, I'm taking out the bad trees, which is good, but I'm also taking out the good trees in that row. There's no selectivity. I'm taking out every tree, whether it be good or bad. So if I can have a logger select, or I can have a select thinning, mark thinning on that first thinning, that's really beneficial. So then the question becomes, well, if I'm planting rectangularity, what does that do to the yields? We found that rectangularity ratios of between to within spacing of the seedlings of 2 to 1 to 3 to 1 really does not impact yields much. I'm reducing my reforestation cost, putting out less herbicide, putting out less, using less fuel, less labor, so forth, and I'm basically getting the same yields. So if I'm planting more seedlings in a row, I'm going to have fewer rows, and as I've already mentioned, right, if I can then eliminate one of these rows through the combination of lowering the planting density and rectangular spacing, I should reduce my labor, reduce my fuel. If I'm coming over the top of the banded herbicide application, I should be able to reduce the cost of that. I'm going to have less use of chemical environmentally. That should be beneficial. So there's many benefits to rectangularity. I can get that fellow buncher perhaps in those rows easier, so that I don't have to do a row first thinning. I can do a select thinning on the first thinning. And so here's a square. So the spacing between rows, between seedlings, and then the spacing within a row, right? Squares, the same distance, like a 10 by 10 feet between rows and 10 feet within a row. This is 1.5 to 1, 1.5 between to within. And then this is about a 2.67 between rows to within. So you can see I'm going to reduce the number of passes here substantially compared to square for basically for the same planting density. Then we're talking about Bareroot versus container. So generally we're going to try to plant seedlings from December to the end of February, perhaps the first or second week of March, but usually up until the end of February. That's the optimal time, whether Bareroot or container. Container, though, has the advantage of often having an extended window because you have this little microsite. So here we're looking at a container, and here's a Bareroot, right? There's no soil around the root. So I can extend that planting window from October to November to April beyond December to March usually. Now, I really don't want to be planting in March or April, but if I have to. When would you have to? Well, let's say I have 10 acres or 20 acres. So the planting crews, they're going to want to work on those 100 or 200 acre tracts. They're not going to want to be going around moving all the time on 10 to 20 acre tracts. So it may be that I'm going to have to, as a smaller landowner, I'm going to have to plant on an off time. If I could plant container, and I could maybe get a crew out there in October, November, or say March or April. Beyond that, if I plant early, I can get earlier herbaceous weed control, say like in February or March, which can be beneficial. Then generally, though, container is going to cost more relative to Bareroot. So there's a little bit of an advantage to the container in terms of survival. So the genetics is genetics. Basically, we feel, most reforestation foresters feel that genetics is genetics. If I get a bare root to survive, it's going to behave the same as a container. The difference, though, is that container, that little microsite, is going to give me a little bit of an advantage in terms of survival. So here's a bare root, and you can see the irrigation. It's being fertilized. It's it's kind of living in heaven here. It's on vacation in here. Then I take that out, plant it here to this cutover site. Well, which one do you think is going to have a little better ability to have a reduced amount of transplant shock? Well, most definitely probably that container, because of that little microsite. That's kind of what we're referring to. Generally, the container is going to buy you on survival. But if you get 95% survival for both, which you can have, right, then really the container I don't think it's going to help you much. Beyond that, the container is a little more forgiving if you don't take the best care of the seedlings. And we never know what Mother Nature is going to do. It could be that the week that we happen to plant is not the best week, so the container can be a little more forgiving. Then we talk about seedling type and genetics. So you have open-pollinated, mass-control-pollinated, and varietal. So the gist of it is open-pollinated is I know the mom, but I don't know the dad. So I have the mom tree, and then the pollen coming to the mom, I don't really know, but usually I'm growing these seedlings anymore in these orchards. So in many ways I'm also controlling dad, but not per se as much as mass control pollinated. Nonetheless, I know mom, but I don't know dad per se. Now, if I come over to mass control pollinated, here I have mom, and now I'm bringing dad. So now I'm controlling the pollination. So mass control pollinated. Now I know mom and I know dad. So these are generally going to be better. MCPs are going to be better than OPs. Most often we find, at least for the most part, conceptually. However, they're gonna cost more. So OP Bareroot is about $60 to $80 a thousand. Container OP is about $150 to $200. So it's definitely going to cost you more for that container on perhaps that survival or that extended window, but that can be beneficial. Then when we compare mass control pollinated to OP, it's about $150 to $275 per thousand, depending on select, elite, depending on the type of MCP that you're getting, and compare that to the OP, and then you have the container MCP. So you have all this going on when you're selecting your seedlings, and here's just the cost. So this is kind of your Bareroot OP, and then you could think of this as your MCP container, and then you can see as you increase your planting densities, the cost per thousand seedlings, the cost for the seedlings is going up, plus you're going to plant more seedlings. So think about the type of seedling that you're planting and the density. And then you have these varietals, and these are really too expensive right now. Those are actually clones, and really for most landowners, you're not going to plant varieties. Then we have genetics, genotype. So a lot of times we've moved from the Atlantic coastal plain west because of faster growth rates, and then we've moved sometimes east because of better fusiform rust control. You should consider the seedling source, particularly if you get more droughts, that maybe you want to keep a Mississippi seed source that may not grow as fast as the Atlantic coastal plain here, but you maybe have a little more confidence in your survival. I'd say all the southern yellow pines are 1-0, 1 year in the nursery with no zero transplant. Here's some dibble bars and the hodad. This is container. This is Bareroot often. So then we get into planting depth, and with loblolly, shortleaf, and slash, you don't really want to plant shallow. Never want to plant shallow. So shallow would be like this. And on real wet sites, you can plant at the ground line, but most often you're going to want to plant a little bit deep. So this a little bit deep. So that root collar, the root collar here should definitely be probably at 4, maybe 3, but probably in between 4 and 5 is the optimal. That's going to give you a little better survival during freezes and during dry years, because that seedling should be closer to the water table when you plant it a little bit deeper. And then of course you have your longleaf, and you never want to plant longleaf shallow because that'll kill the bud. And you don't want to plant deep. You should never bury that buds. But you want the bud above the ground. You never want to plant longleaf deep. So that's the loblolly, slash, and shortleaf, plant deep, but don't plant longleaf deep. Plant it a little bit above the ground so you can see a little bit of that. And then most of the longleaf anymore is container. So you're not really seeing a lot of bare root. So you always want a little bit of that plug to be shown when you plant. So then we talk quickly about some approaches to reduce reforestation costs. So we talked about reducing planting density, rectangularity, maybe planting bare root OP if you're more interested in wildlife habitat, or you're interested in recreation or owning property and just having a forest. You don't necessarily want to maximize financial returns. You don't want to have that risk involved, that financial risk. You can plant open-pollinated bare root. Anyway, you can kind of decide what's best for you. Then OP and MCP, right? Open-pollinated, MassControlPollinated. The cost involved with those. So another thing is you can compare your chemical site prep with your herbaceous vegetation control. So generally, we're gonna conduct chemical site prep. We're doing a lot more chemical site prep than we were, say, 40 years ago. We're going to often do that sometime probably June to maybe September, real late October, but usually June to August to September. And we're going to control the vegetation out there, but usually you're not going to get long-term vegetation control into the first part of the growing season. Then that winter, say December to February, we're going to plant our seedlings. Now then, of course, right, when it comes to be March and April, getting into the spring, well, now the competing vegetation is going to be out there, particularly the herbaceous vegetation, but the woody as well. Hopefully you've controlled the woody in the site prep, but the herbaceous vegetation is going to come out there. So we often do a herbaceous vegetation control treatment early on, coming over the top, usually in a banded application. This is both pine and hardwood. But the point is that by pairing those two together, you may lose a little bit on the efficacy, say like in May or June or July maybe, but you can reduce the amount of total cost because you're only having one application during for both of those chemical applications. Then take advantage of the federal reforestation tax deduction and amortization, the state tax credit, most definitely. You should definitely consider your income tax classification, whether you're a business, investor, or hobby personal use. That can help you, say, with things like casualty losses. Cost shares, there's NRCS and FSA. Some private organizations, but usually those are a little more for hardwoods. And then you can even do like mixed genetics plantings, like plant one row of MCP with one row of OP. So those are some ideas to reduce your reforestation costs. So then to finish up, some advantages of planting. Well, you can better control the stocking, particularly at younger ages. You don't need pre-commercial thinning. Sometimes we'd get like 5,000 or 10,000 seedlings per acre on a natural, and you don't have that problem. Very good control over the genetics and consistent spacing, right? You can have 12 by 6, 12 feet between, 6 feet within rows, 10 by 10. I can control that spacing. Earlier financial returns often, but now with our inability to do pulpwood thinnings, that may not necessarily be true. More straightforward if I want to do a species conversion. So if I want to go from loblolly to longleaf, say in southern Mississippi, and I don't have any longleaf near my property, well, it's going to be very hard to do that naturally, so I'm going to have to plant. And reforestation is not dependent on seed years like with natural regeneration. So now there's some disadvantages. Higher regeneration costs relative to natural regeneration can be unesthetically pleasing. This is a pioneer species and it needs sunlight. The pine species. Often heavy equipment to conduct site preparation. I can have problems with L rooting or J rooting where I don't have the planting hole depth correct. That I don't have that with natural regeneration. And sometimes, ironically, the faster growth, I can actually have more problems for some time with insects and diseases. Thank you.